Hi, welcome back to Mike Makes It. This is part 2 of me fitting a DRO to the little lathe I have. We pretty much covered the x-axis, the cross slide. I was waiting for some bolts. They've turned up now, so towards the end of the video we'll refit the X and set the head up. So hopefully that'll work out right. I'm working on the Z-axis now on the back, the main carriage reed head, this one. Scale and reed head assembly. Now I've got to mount that, well I haven't got to, but I am going to mount that on the back of the lathe. So I'll get the camera set up and show you the problems I'm going to incur. Alright, we're looking at the back of the lathe bed now. We've got an angle here, it's about 60 degrees from the top slide area. Now that's going to cause me a mounting problem for the scale. Now I could mount it flush onto the carriage bed, or the lathe bed here, like that. But I'm going to have a weird bracket coming out from the head to attach to the moving carriage. I'd prefer to mount that at 90 degrees with respect to the top of the lathe bed here. So with that in mind, I've come up with a little bracket. And that will simply mount on to the top of the lathe bed. I can put a hole in here that's going to correspond to where I want the hole in the lathe bed. It's about 30mm block thick. I think it's actually a little bit more than that. So that'll stabilise the drill and hold it in the correct position for me to bop 2 holes in the lathe bed. That's the plan anyhow. This end you can just about see, got a motor here, and the motor's in the way of me drilling a hole, so we've got to have to dismantle the front end. But I'm going to start here first because that's slightly simpler. I've got one more hole to put in here. That's going to be for a 4mm drill to go through and basically mark out the bed and drill it and tap it. Probably going to tap it to 6mm, which is going to support this quite well. It's going to be on a stud so I can move it in and out a little bit just to get the fine tune. So that's the plan. I'm going to finish this and I'll come back when we're drilling holes. Some progress has been made now. This is this little guide block I've been making up. Well, I finished it. We're going to about see if it works. But I've got 3 holes in the side there, in the end. 4mm, that's going to be my pilot hole, a little bit big really, but there's no length in the 3mm drills, not long enough to reach anyhow. So 4mm is what I'm stuck with. 5.2mm hole for 6mm tap. Follow through after the 4 of course, and that's a 6mm hole for the tap to go through. So hopefully everything will be kept in a line. If you look at the side of the bed there, the front's actually fairly square, but the back, as I say, it's 60 degrees. So yeah, that's what we're going to do. Put my little guide on, see if I can drill a hole. Alright, that's the bracket mounted on the lathe bed. It's in the right position for where the hole needs to be drilled. And hopefully you can keep track of what I'm doing. There's 3 holes there. It's the lowest head I need. I've got a 4mm for the starter drill, if you like. 5.2 for the tap size. And I've actually done a 6mm as well to keep the tap steady when I'm tapping the lathe bed. So we'll start off with a 4mm. I'll try to stay out of shot. Just nice and slow, that's all I want, because there's a chance of busting off the drill, because we're going uphill effectively. I think this is what's called an induction heated lathe bed. Very, very hard, although we are making progress, so... Right, we had a slight hiccup here. The shank on the 6mm tap is bigger than a 6mm hole. And I've had to drill the hole out a little bit larger to accommodate the shank. We're barely reaching with the tap, but it's starting, so I'm going to get probably a dozen threads in or so that I can take over without the jig. So should be okay. It's a bit of a long-winded way of putting 2 holes in the back, but nevertheless we've done it now, or we've done 1 hole. We're going to do the second in a minute, which is going to be an even bigger problem because the whole motor's got to come off this end. Let's get the WD out the way. I'll slide you up the other end. Yeah, the hole's got to be, you can see the motor there, it's under here, so obviously I can move the carriage down, but I can't get a drill in because of the motor's in the way, so the motor's got to be took out. I'm going to finish tapping the easy hole, then go and get a cup of tea, and this motor's going to come off in after I've had my tea, so you'll be back to watch that. I've removed the motor now, so I can get to the second drill point. I've used a little pointer on the actual block itself and measured the distance from the existing hole to where I need the second hole to be. So hopefully, so long as that's measured okay, I should be good. Right, I've drilled through with 5.2mm like I said I was going to do. I've edited the video because all you could see or would have seen is that, so that's not very interesting. I'm going to go through with a 6mm tap now, and hopefully next thing you'll see is the scale fitted. Right, just before I fit the scale, one problem I'm coming across, because this bolt is in 90 degrees to the lathe base, when I do that bolt up, that effectively is going to twist the position of the bolt. So what I want to do, and I've made one already, is a little bit of aluminium, if I get my fingers out the way you can see, like that. Now that'll effectively slide over the bolt. The little bit of an angle is going to be the same as the base, so in theory when I put a nut on here and this is on the base itself, it should lock up nicely without skewing the bolt at all. So that's the plan anyhow. This one is for the other end of the lathe, you can't see. I'm just about to cut the one for here on the Axminster saw, so we'll go over to that now and we can have a little look how we get on. Right, just setting the Axminster up for its second cut. I had to reset it so we could get 90-degree cut on that little bit of hex bar. Now, to get the angle I need, I've got to move the vise over to the right-hand side. You've got a couple options with this, 0 to 45 on the left and up to 60 on the right-hand side. Now, something I didn't realise, which I'm very pleased with, it just goes to show the Axminster seems to be of a fairly good quality, is that the vise is dowelled. By which I mean, if I lift that out and get this on shot, where the bolts go through, you've got a couple of locating lugs or dowels, and that's very, very nice as far as I'm concerned, because you pop it back onto the machine, you've got no wibble wobble. So if you hadn't done the bolts up tight enough, the vise isn't going to shift on you. So yeah, accuracy is fairly good there, which I'm pleased with. As I say, it's something I wasn't aware of until I've actually moved that vise over. You can't get a 0 cut with this because these bearings hit on the vise there, and unfortunately if you've got a long bar in here, you can't have a long bar in there if you're going to cut 60, because the hydraulic system to lower this down slowly gets in the way. So a couple of little issues there, but you can get around those. So all I'm going to do now is set up the angle I want. That looks good, so away we go. There you have it, that's what we're looking for. Right, drill the hole out, 6.5mm, and back to the lathe. Well, there you go, that's our little spacer, cut to about 70 degrees. So basically it means I can lock the nut up so the thread or the bolt doesn't move without risking cocking it sideways, basically. So that's good. I've done the same behind the camera, as you can't see. So now I can actually fit the linear scale. There's going to be some adjustment here, nuts, washers, etc. but basically you've got a good base to work from. So that's what we'll do. Let's find the scale. There's a shorter scale. All I'm using this for at the moment is to mark up these 4 holes into the aluminium bracket, which, if we go over to the lathe, is what's going to be mounted on the reed head down here. So this is on now. This is what I said I was going to do. Well, I've got to dismantle it to set it up properly, so we can look at doing that in a few minutes. But at the moment, what I want to do is make this bracket, knock 4 holes into it, and make sure it fits this head. The other head is identical, so basically, rather than taking the scale off that I've already temporarily fitted there, I'm using this one as a template. So that's what we're going to do now. I think what I'm going to try to do is put a piece of paper on there, just push down where the holes are, to give me a little template to put onto this. Failing that, I can do some measurements and knock it over. Either way, I'm going to make these holes larger than they need to be, just so we've got a little bit of wiggle room. I've got to make sure we've got a little bit of play in everything so we can adjust it up quite well. So yeah, mark this up, drill 4 holes, away we go. We'll try the paper method for now. Works well if you've got dirty hands. Just a sheet of paper. Holding on the reed head, so I don't want this paper to move once I've started marking. But rub your hands down the side, and you can see where the screw holes are. Actually leaving a mark from my hands. Do the same the other end. It's going to be accurate enough for what I need to do here. As I say, I'm going to make the holes bigger than they need to be, although that'll introduce wiggle room, which is what I want. But if you look at that, we now got the marks for the reed head. So I can cut that out, move that over to the aluminium, bop a couple of centre punches in, away we go, drill holes. So that's what we'll do now. I'll only get one chance of this. If not, I'll have to do it again. But should be good. Bit like Blue Peter. Right, here we go. Very sticky, this tape. So yeah, just a couple of centre punches, drill some holes. Good, all good. There we go. Over to the pillar drill. It looked like 4mm bolts, so I'll probably drill these holes out of 5. So we'll go over to the pillar drill. I just need to clean these up a little bit and trial fit it. That's the plate cleaned up, so we'll try. It is 4mm bolts in here, so always handy to keep a selection of nuts and bolts. That's what I find. You build them up over the years and away you go with them. Not sure if I can use washers on here because they might be a little bit close, but not the end of the world if I can't. But I'll say we'll trial fit this, then this can go on the other axis. But yeah, that paper method with having dirty hands, a little bit of paper, marks the holes out very, very easily and quickly. And that's the main thing these days. There you go. And we've got the wiggle room that I want. Not massive, but I'm doing as accurately as I can, and with a bit of wiggle room should be good. So yeah, we'll put this back on, or we'll mount it for the first time on the other axis. Alright, let's see if we can get this set up. I'll show you the way I do it. Other people may have other ideas, probably better ideas. However, this is working. So basically I've got 2 studs on here. You've seen me drill those out. What I've done now is Loctited them in with stud lock so they shouldn't move. We've also got the little spacer that's cutting at an angle here to marry up with the carriage. So I'm going to put, I've got a nut here which I can adjust on both sides, and 2 washers just for strength. So in go the washers. I haven't mounted the bracket on the bottom of the reed head yet. I'll do that later. For now, I just want to put this on, trim it for left to right, up and down. So that's what we're doing now. A couple more washers on the front. I'm going to go for a couple of spring washers as well. Vibration of the lathe may set it loose. We'll see in time if that is going to be a problem or not. Now we've got movement on the scale up and down, so what I'm going to do, just go to about in the middle so I can go either way with it. Just nip that, same with the other end, about halfway. Just nip that as well. I'll bring my dial gauge in. I'm going to use this angle first. I'm going to set this how square it is to the main deck of the lathe, because what will happen if I undo the nuts to move it in and out later, the actual horizontal position could shift. So if you like, I'm not sure you call it the vertical position, but this is the way I'm going to do the parallelism, if you could pronounce it, with the main chassis. So I've got the dial gauge set here. We'll go as far as I can to the right as I look at it, and we'll zero the gauge out. We're measuring 0.01 of a mil per division here. Not ideal how I'm measuring it, but I'm measuring it on the flat with this bar that's in at 90 degrees to it. So there's going to be a little bit of wiggle wobble either way, but we're on 0 at the minute. We crank it down there. We got movement at 10 divisions, so it's 0.1 of a mil so far, 0.15, 0.2, 0.25, and we're still going 0.3 of a mil out. So what I'll do here, loosen the nut, move the nut on the other side a couple of flats, and do it again. Get as far as we can over, zero it out, 5, 10, 15, 20, so some improvement there. As I say, just a matter of little movements at a time. Couple more flats. I'll have to go through this again once I've got the reed head bracket on, but I just want to make sure I can actually set it up quite accurately, and just on that, the nut and bolt setup seems to work quite well. Well, let's see what we got now. Now that's actually low by 0.07 of a millimetre. So we'll take this in half a flat. And try again. Right, pretty much zeroed there. Now I can only get it so good this scale itself could be slightly deformed because that's going one way then the other, but we've got on 0 there. Let's take the slack up in the bar. 0.01. That's 0.03 of a mil8. Staying about that 0.04. 0.01. So that's not too bad. There's a little tolerance in the head itself because it's on a spring set in bearings and runs on the aluminium extrusion. So that's not too bad. I'll move it up onto the top and I'll do the same with this position, the horizontal to the bed. This position shouldn't move when I undo the nuts, but of course this position will, and that's what we're looking for. So I'll adjust that up and get that set sort of halfway decent. Then I'll need to make a bracket for the back, and that'll attach to a similar bracket to this that you saw me drill out earlier. So yeah, I'll strip that off, set this up a little bit more accurately, and we'll go ahead and make a bracket for the back to pull up from the reed head. Right, got a bit of a plan going on. This is where I want to mount a plate. One of them I've cut. A piece of aluminium plate that I had scrap. Now there's a hole already in the back here which I can't use. 10mm hole. There for the adjusters for the carriage. So I want to leave access to that. But what I've done, I drilled a 10mm hole through there. Let me get my bolt out. Right, the plan is to use that bolt hole temporarily to mount the plate, like so. I'll make sure this is square. I'll tighten the nut up, and with the 4mm transfer punch, I've done an earlier video on the transfer punch, it's very, very useful. That'll go through a pre-drilled 4mm hole, bop with a hammer, same over there. I've transferred the marks to this. I won't have to build a jig like I did for these bolts. I'm just going to go freehand in here, probably go to 5mm bolts. So I'm going to have to drill about 4.2mm hole for the tap them out, bolt this plate on. So I think that's what we'll go ahead and do now. Well, there's the plate fitted on there. I've squared it up, got the holes in there ready to go through with the transfer punch. So we'll do that now. Hopefully it isn't hardened carriage, otherwise I may have some issues drilling it. Don't want it too hard because I don't know where the transfer punch is out. I can resharpen them though, hopefully on the lathe. Right, that's done. We'll take the plate off, see if we got some marks. Yes, we have. So I'll go and drill those out, tap them, and I'll show you when the plate's refitted. Right, there you go. That's all the metalwork reassembled for the Z-axis. Reed head's all bolted on. The scale's been calibrated. That's give or take 0.01 of a mil, which I'm very happy with. Now, I've got this to fit. That's a bit of a screen or a guard to put over the scale itself to keep all the swarf and oil and everything else out. So I'll go and put that on now, and I'll show you what it looks like then. Right, there you have it. Got the dust shield, grease shield on, whatever you want to call it. And a bit of cable management going on. We may have to just rejig that a tad because the motor's got to fit on this end bracket, so it may get in the way, but I think like it is, it should be pretty much foul free, so to speak. Forgive the camera for rocking, I'm just winding the handle there, moving it along the Z, so that should be okay. What I will need to do is make sure this bag of cable here is free to slide up and down with the carriage. So once it's all put together, we'll see how the cable slides along the back here. I may have to do something to lift the cable up somehow or other, sort of in the air kind of thing, but hopefully not. But right, that's the Z. Let's get on with the X. Well, I'm back on the X, just reassembling that. got an aluminium plate on the carriage that slides backwards and forwards. Same thickness aluminium plate on the carriage that slides left to right. In other words, the one, let's show you, look. There you go. And basically, the reed assembly, the linear scale, is going to be bolted to this, and the reed head is going to be bolted to that. And if, I don't know if you can, you know, it's all in line basically, so all I should need to do, drop the scale down like that. We'll align it level with the top aluminium bar there. I've checked for parallelism here with respect to the reed head, and it does run out of fraction with respect to the main carriage, but I've straightened that up with a little shim this end of the block. So we're running 90 degrees to one another, so the accuracy should be fairly good. Through these two holes, this is what I'm actually going to mount it to the lower plate. I've done 3mm bolts through a 4mm hole, so I've got a little bit of wiggle room. So I think we're all good. I'll finish bolting that together. The Z-axis is all on the back finish, as you saw. All I need to do is a little bit of cable management and find somewhere practical to mount the DRO. So that's what we'll do now. All right, all powered up. Pretty much there now. Done a bit of cable management. Some P-clips there with the cables running down. Mains runs down the back of the window. Some time ago I fitted bars in the garage, the workshop, to keep me in. And I'm utilising those with a bit of bracketry I've made up. Just out of a couple of alley blocks. Forming a sandwich. Very, very good and strong fixture, that is. That's not going anywhere. This bracket came with the kit, the DRO kit, and there's a little bracket on the back I've bolted to the alley plates. Cables all tucked in at the back there. At the moment, these are just running down the back of the lathe. Most of these cables are P-clipped up, with the exception of the X. I just need to do something with that. I don't like that hanging down the back. I've got a cover to fit on that. But let's just check the accuracy. So we've got a dial gauge set up here. You'll see resting on the lathe, wind it in on the Z. Let's say we go 2.5 on the dial gauge. We want to zero it out. Now go 3.5, why not? Overshot. Right. And again. Okay, 3.5. Zero the Z out. Remember 3.5. Oh, there you go. Just a tad over. And do that again. So there you go. Pretty good. For £150, bought me 2 scales and the DRO itself. I went for the 3-axis one. You never know, I might be able to use that perhaps on the pillar drill. But it's all done. So I'm going to be using this tomorrow. Going to earn some money. Well, that's the plan anyhow. So I've got a little cover to put on that. Tad more cable management. But this DRO does a lot more than absolute X and Z. And that's initially, that's all I wanted for. Find out where the cutting tip is while I'm on the lathe. But I've got a middle attachment, as you probably realise. And this little thing does a lot more than simply left to right, backwards and forwards. So once I've got the hang of this, and I've learned how to use it basically, I may do a follow-up video just to show you what the DRO can do. Because I thought they were quite simple, but no, much, much more to it. But anyhow, thanks for watching the videos. They've dragged on a little bit, but I hope you found them interesting. I've certainly enjoyed doing them. And this will be absolutely terrific addition to the old lathe here. £150 all in, a few hours of my time, and we got a modern lathe. Anyhow, thanks for watching.